Hello, my name is John Horton. I'm a professor at NYU Stern, and I'm an applied microeconomist. And I want to talk a little bit about a tool that I've discovered a few years back that's become a really important part of my workflow, and that is Make, which is basically a tool for orchestrating, a software tool for orchestrating the building of sort of complex software projects, but it's kind of well adapted for the kind of work that a lot of empirical social scientists do. So here I am at the command line, and let me just make a directory that we can go work in. So if I go over to the tutorial, it's empty right now, but say I'm going to make a plot. I'm going to create an R function called coolplot.r, and let's just do something kind of silly. We'll load ggplot2. We'll make 100 random numbers from a uniform distribution, and then let's just plot it. And so if we run this, well, actually, let's make it executable. User bin environment R script. So if we go back to the command line, make it executable, and we run coolplot. Okay, you can see a little message telling us that something was happened. If we look in here, you can see that there is an rplots.pdf, and we open it up. See my messy desktop, and sure enough, we get this plot. Now, if we go back here, and let's actually save. So we'll just do PDF, plot, PDF, device off. Okay. So now this is just going to save, when we run it, it'll just save that PDF. And if we open up coolplot.pdf, there it is. Okay, so now let's take and use a makefile. So the use case here is, suppose like we made some change to our code, and whenever the code changes, we want the coolplot.r to run again. So we make a makefile. The makefile is just called makefile. And what we do is we spell out the files that we want to create. So here we want coolplot.pdf, and then we have a colon, and we specify what this depends on, meaning what is the file or files that, if they change, I want to remake this thing. Now then, so it's just coolplot.r, 2, 3, 4, and then here, 4 spaces in, we want to specify the recipe, which is essentially what do we want to run to make this thing. And so ours is just coolplot.r. Okay, so now if I run coolplot.pdf, I have a problem. Let's see what it is. It seems to be okay. Make coolplot.pdf is up to date. Okay, now watch if I take and say change coolplot.r in some way. So say I take and increase, so it's now 1,000 points, and I save it. When I run coolplot.pdf, you can see it takes and goes and reruns my code. And now if I go and look at coolplot.pdf, you can see it has a lot more data points, right, reflecting the change. So, where do you go from here? Well, what you can do is you can specify all the dependencies for a paper. So every table, every figure can have an entry in the make file, right? And so when you change any code, only the parts that need to update will actually run again. And what's nice about this is you don't end up not having to run your analytic code. You make some little tweak and everything has to run again. It only has the parts that actually might change. And another nice advantage is it just kind of encourages a very modular style of coding where you just have a snippet of code to make one thing, and that kind of cuts down the complexity of what you're trying to do. So there's a lot more you can do with Make. This is probably just enough of a baby introduction, enough of a start, so you can kind of see what it can do.